Hello and welcome back to the Lehigh Energy Systems Engineering Zoomcast series. This is the third Zoomcast of the ESE Spring Semester series where we cover Laura Marsiglio presentation titled The Energy Trilemma, Utility Strategy in New York Regulatory Environment. Laura is an alumnus of the Lehigh University Master of Engineering Energy System Engineering. She also has a background in materials engineering, economics, and environmental policy, which she acquired through the Interdisciplinary Engineering and Social Science Ideas program during her undergraduate studies at Lehigh University. Laura has been working as an associate analyst for the New York Transformation Planning at the National Grid for over a year, where she collaborates with various stakeholders to create short-term and long-term strategies for enabling the transition to clean energy. The Climate Leadership and Community Protection Act lays out the strategies for New York that utilities need to follow for achieving a successful energy transition, which aims at 85% reduction in greenhouse gas emissions by 2050. Laura started off by discussing National Grid's strategy to navigate the energy trilemma, with the vision to be at heart of a clean, fair, and affordable energy transition. The National Grid strategy takes into consideration all three aspects of the energy trilemma, with options for decarbonizing their gas networks, technology to support renewable generation, investing in grid modernization, and building out infrastructure to ensure reliability. While the National Grid has strategies in place to enable the clean energy transition, the impact of electrification, which is expected to double the state electricity demand by 2050, will exacerbate the challenges for clean energy transition. So, Ahmed, what are some modernization technologies that can be considered for New York's reliable and resilient grid?
Sure, Corey. New York is shifting toward an increasingly distributed energy system powered by the first mix of uh, small and large scale renewable resources connected to the grid, deploying renewable energy technologies, including solar arrays and offshore wind turbines, geothermal power resources require the extensive transmission and distribution infrastructure, as well as energy storage to deliver clean energy from where it is generated to where it is needed. Moving away from more centralized power generation towards an increasingly diversified and flexible energy system helps bring resources closer to customers, improving grid resiliency and air quality across the state. Yet, the effects of climate change, such as extreme heat and severe weather events, as well as cyber threats and aging infrastructure, present risks and disruption to our clean energy system. As New York State strives to meet its climate targets, building a distributed energy system that advances resiliency and equity is essential. Transforming New York electricity system for a zero-emission future will require upgrading our transmission lines and distribution system as we integrate more renewable generation and energy storage in the grid. It's also essential that we upgrade and design our energy infrastructure to withstand and adapt to climate risks and threats. Particular focus on addressing disproportionate impacts to disadvantaged communities. New York State Research and Development is working with cities, innovators, communities, and other state agencies to advance solutions and investment to achieve a resilient clean energy system in New York. And I'm going to I'm going to explore some of the tools used, leading by example by factoring resilience and energy, uh, clean energy goals in state government operations, identifying and implementing best practices around climate resilience in partnership with other state agencies through the Extreme Heat Action Plan. The Extreme Heat Action Plan will include the development and implementation of an extreme heat adoption plan and a comprehensive state extreme heat emergency response as part of the state comprehensive emergency management plan. This complements the energy assurance planning and coordination by New York Research and Development and other state agencies to bolster the resiliency of the energy supply chain serving the state. Uh, Spearheading next generation of climate adaptation research to provide insights for infrastructure investment and energy system planning decisions based on new updated climate projection data. Steering the development and the integration of a wide array of smart grid technologies that support a distributed energy system and advanced resilience, including energy storage, smart demand response, and vehicle-to-home grid flexible charging. Continuing to administer and refine flagship distributed energy resources programs like New York Sun and energy storage incentive programs that boost resilience, provide grid value, and reduce cost. Thank you.
Thank you very much, Ahmed. Now, Alex, Laura spoke about the growing demand of electricity, expected to double by 2050. What are some of the demand management strategies that can be used to reduce the electricity demand in New York?
Yeah, sure thing, Corey. So, National Grid has a few demand management strategies, but nothing very substantial as of yet. For Grid to fully realize its demand management capabilities, the Public Utility Commission would need to change the pricing structure for residential rates. Right now, residential rates are adjusted monthly. In the future, the Commission should allow a shift to time of use billing. With TOU billing, rates change from hour to hour. This allows private households to respond to changes in pricing and take advantage of energy efficiency improvements and load shifting. Historically, TOU billing sees a 20% reduction in peak demand from market signals alone. Grid is prepared for this change by supplying many of its customers with smart meters. These meters can communicate with Grid in real time to show energy demand and on-site production. Smart meters help Grid understand how demand fluctuates in real time. Once TOU billing is introduced, these meters will inform customers about real-time energy rates. As customers become aware of increased prices, they can respond to the market incentives. Lowering peak demand has many benefits. First, it decreases the strain on the utility. Second, it can prevent peaker plants from coming online. Peaker plants are expensive and run very inefficiently. As a result, they heavily increase the price of electricity and release large amounts of carbon into the atmosphere. Keeping peaker plants offline allows the highly efficient baseload power to power the grid. Beyond lowering demand, Grid has made large investments in its infrastructure to shift around electric supply. The Advanced Distribution Management System, or ADMS, gives the utility a better handle on different grid management tools. Some of these tools include capacitor banks, DERs, transformers, and switchgears. Grid can use these tools to balance out voltage, increase power generation, and direct where the power flows. The ADMS system works hand in hand with the Distributed Energy Resource Management System, or DERM. The DERM controls smaller items like EV chargers, smart electronics for consumers who have opted in, solar inverters, batteries, commercial and industrial devices, and water heaters. With better control over these smaller resources, Grid can bring these devices on and offline in mass. Taking EV chargers, smart electronics, water heaters, or CNI devices offline will lower demand. Bringing distributed generation and batteries online will increase capacity. Between the ADMS and the DERM, National Grid is poised to take control over the grid. Due to their size difference, the ADMS typically works on the power transmission end, while the DERMs work on the distribution end. They meet in the center at the substation. By digitizing the control over all of these assets, power operators can give AI the reins to optimize the grid, shifting loads to meet power supply and minimize the overall electricity cost. The end result should be a more reliable power in a world with less reliable generation. Back to you, Corey.
Thank you very much, Alex. Michael, over to you. Give me some examples of clean energy resources that can be deployed in New York to meet the 2050 goal of 85% greenhouse gas reduction.
Sure thing, Corey. National Grid is a major natural gas provider with a lot of this gas going towards home heating. However, to meet New York's 2050 goal to reduce greenhouse gas emissions by 85%, they're looking into cleaner fuels and alternative heating methods. National Grid, along with the New York City Department of Environmental Protection, have a renewable natural gas facility in Brooklyn. This facility has massive biodigesters that capture the methane from wastewater and from the decomposition of food waste. Now, normally this waste would just go into a landfill and release methane into the atmosphere. While burning the methane produced by this facility still releases greenhouse gases into the atmosphere, it is much more environmentally friendly than fracking and then burning methane stored in the ground. National Grid is also looking into network geothermal utilizing heat pumps to provide heating and cooling services to buildings within New York City. Since the ground is cooler than the outside air during the summer and hotter during the winter, a network of underground water pipes would be installed and connected to buildings. Heat pumps within the buildings would harness the warmer or colder temperature of the water to provide heating or cooling services. There are many benefits towards utilizing the geothermal energy for HVAC systems. Since the ground temperatures are more stable than air, geothermal heat pumps are more reliable than air source heat pumps. Additionally, geothermal heat pumps are more efficient, reducing overall peak electric demand for when more people start to utilize heat pumps. Lastly, there's already a skilled workforce available to install the geothermal network and heat pump systems. While the benefits may be clear, this type of project would come with a good amount of challenges. First off, the system would require a large amount of new infrastructure, which would take time and money to install. Customers may not be willing to live through all this construction, so it may be faced with a lot of public opposition. And then, these customers must also choose if they would like to be connected to the network, furthering customer adoption problems. I know from experience about 2 years ago when I was living at Moravian, UGI was replacing pipes along the front street of my house. It would take them around 2 to 3 weeks just to install piping down maybe 3 blocks. It was fine during the first few days, but after a while, I started getting annoyed with all the loud machinery and road rerouting. So I can only imagine how the population would feel for a whole new network of pipes being installed all over the city. So, due to the large amount of infrastructure development needed for the network geothermal, this type of project would be long-term and considered a final solution for retiring natural gas within New York City.
Thank you very much, Michael. The discussion on the deployment of clean energy sources in New York to meet the 2050 goal of 85% greenhouse gas reduction was particularly enlightening. It highlighted the efforts of the National Grid in exploring cleaner fuels and alternative heating methods, such as renewable natural gas facilities and network geothermal utilizing heat pumps. They provided valuable insights into the complexity of the energy trilemma and the multifaceted strategies required to navigate it. It underscored the importance of innovation, collaboration, and forward thinking in achieving a successful energy transition. The discussion served as a reminder that while the path to clean energy future is fraught with challenges, it is also filled with opportunities for technological advancement and societal progress. Well, this sums up the third Zoomcast in the Lehigh Energy Systems Engineering Zoomcast series. I would like to thank Laura Marsiglio for making time to present and discuss the Energy Trilemma utility strategy in New York regulatory environment. Be sure to come back in 2 weeks for our 4th Zoomcast where we cover Wabiki Permin seminar on hydrogen and supply chain.